life on Earth, the sheer diversity of living organisms, all across the planet's history. All of them are here because of one specific moment in time. Before this moment, life were mere cells or senseless blobs floating around in the ocean currents. Until one innovation was made. One adaptation that caused a boom in diversity. One adaptation that caused creatures to start evolving rapidly, more rapidly than ever before. An adaptation of predation. As creatures, back in the Cambrian era, began to actively feast on one another, they were forced to evolve ways to avoid enemies. Some grew shells, some more mobility, some new sensors, and still others more weird and wacky types of defenses. Still then, predators found a way around those, creating a cycle of adaptation and evolution. On Earth, this event was known as the Cambrian explosion, and ZIRA will have its very own as well. Starting from a single clade of specular spondyle, which has gained a taste for flesh.
Oh yeah, hi, I'm Zachbot, and I'll be your host for the evening.
The simple benthic habitats of ZIRA won't be so simple for long. You see, as the trichinoa and specular spondyle begin increasing in population, so too does the competition. And slowly, things like food will become more and more scarce, eventually forcing evolution to shape new forms entirely. One such form could derive from the specular spondyle. To avoid the ever-growing competition, some specular spondylls may evolve to use their rudimentary legs to push against the water like a paddle, allowing them to leave benthic environments for short periods of time. As these creatures evolve to leave the seafloor more often, they would need to make some more adaptations to make free swimming more efficient. Their legs may broaden and become similar to flat paddles, with even their back leg doing something similar. Some of you may recall something from last episode. The specular spondyle, which this creature descends from, has two simple spines running down each side of it. Whilst yes, the spines are flexible, it's only to a certain extent. Which means that a side-to-side swimming motion like fish on Earth would actually cause unnecessary pressure on the spines. This means it's actually more beneficial for them to swim up and down, similar to cetaceans on Earth like whales and dolphins. Another thing you need to swim well is good eyes. And yes, while the specular spondyle does have eyes, they aren't the greatest, typically only being able to see in black and white. So, to become a better swimmer, this creature may evolve some special cells in their eyes able to differentiate between different colours. The most beneficial colours for this creature to see would be greens and blues, as most of the environment surrounding them is that colour, think trichinoa or metiophyte. Another visual adaptation could be 360-degree vision. They could very simply evolve this just by having their back eye face backwards to the end of the tail. These unique adaptations, colour vision and 360-degree vision, will allow for this creature to become the most effective predator this world has ever seen. And yes, I said predator. The high amount of competition would cause this creature to evolve a new diet. A diet of smaller creatures like the trichinoa, corpses of specular spondyle and their own kind, as well as metiophytes and other plants. Now for a question I'm sure lots of you have been waiting for me to answer. What the hell are these things around its mouth? Well, as the diet of the specular spondyle changes from sucking up marine snow to eating things like trichinoas and metiophytes, they would also need a mouth change. Over time, rings of muscle could grow around the mouth. And to help grab things, these may elongate further and further and further, eventually becoming 3 trunks with mouths on the end, similar to the extinct Opapinia on Earth. This is actually where it gets its name, which from now on we'll be calling this creature the fellaxabinia. Meaning, from the ancestral trichinoa, which had 3 mouths and 3 anuses, the fellaxabinia now has 3 mouths located on the end of 3 trunks, 2 gill holes located behind each fin, and 1 anus located at the base of the tail. And as the fellaxabinia begins patrolling the shallow seas, other creatures like the trichinoa and speculus spondle will need to adapt to defend themselves from the fellaxabinia. Perhaps some trichinoas could evolve burrowing. Introducing the phodiostoma. Burrowing might initially start as a simple behavioural adaptation, simply using their legs, or for a better word, nubs, to kick around at the sand. And slowly but surely, they would eventually evolve to use their nubs as a way to actively push out sand, creating burrows. Phodiostoma wouldn't grow very long, about the length of an earthworm, and would swim around in the seabed, sucking up marine snow and eating softer parts of carcasses, acting as a mini cleanup crew for the early oceans of ZIRA. Their 3 nubs, which are now used for digging, could also be used for grasping food, which would now surround 3 central mouths. Their anuses would move to the side, becoming 3 small holes, also used for breathing when not excreting. Another way trichinoas could evolve to defend themselves was right under their nose the whole time. The seabed is full of minerals. Minerals that could accidentally be eaten by a trichinoa when it's sucking up marine snow. But what if the trichinoa could use these to their advantage, growing a hard, mineralized shell on their backs? Introducing the concamis. This funky yellow fellow is reminiscent of trilobites and snails. Their heavy shells would hinder their movement, meaning their legs would grow long and tendril-like. Their bodies may also elongate further into their spiral shell, creating high surface area for their intestines and stomach. The eyes may move to the very tips of the tentacles. This is due to the fact that when threatened, the concamis is able to retract its tentacles into its shell, allowing it to escape predation. Once fully grown, the concamis does something very special. They send out pheromones saying they're ready to mate, which, albeit on its own, doesn't sound very impressive. But concamis tend to all be ready to mate at the same time, meaning these pheromones act more of a signal to come together. This means, very occasionally, every few years, concamis will gather up in giant groups. They would all interlock tentacles, becoming one gigantic tangled mess. And simultaneously, they would all spew out gametes. This ensures the gametes have a high likelihood of meeting another and forming an offspring. Shout out to Mr. 42/Project Methania for this art, by the way, it's awesome! All these creatures create competition, and this competition may affect the speculus spondles. Most of the creatures that eat marine snow have something going for them. The trichinoas are able to reproduce so quickly it's pretty much impossible to outcompete them. The phodiostoma live subterraneally and often eat parts of carcasses. And the concamis have their shell to defend themselves. But the speculus spondle is kind of just there. Whilst before it had its size to keep competition at bay, now the size is a hindrance, allowing it to get easily spotted by predators. So, whilst it won't go extinct entirely, it would most likely face some population decline. But, to cling on just a little longer, a small branch of speculus spondles may ditch marine snow, instead opting for a strictly herbivorous diet. These speculus spondles will soon become named the Parvasilorum. These herbivorous speculus spondles would spend lots of time in meteophyte fields. Here they would live, reproduce, and go about their days, eating up vegetation and running from predators. But the vast groves of meteophyte might cause an issue. The thick blue leaves could block the vision, allowing them to be caught by predators. The speculus spondles may find a way around this, however. They could grow their 3 legs into tall, stilt-like structures, allowing them to poke their head above the leaves of meteophyte and see long distances. The Parvosaurus would also grow a more complex gut in order to digest the plant matter. They could have a simple microbiome of bacteria-like creatures living inside of their stomachs. These would break down tough tissues, providing nutrients for the Parvosaurus. On each side of their 3 mouths, they may also grow some small muscles. These would open and close around their 3 mouths, which are organized in an upside-down triangle structure, and would aid in grasping and processing food. As time passes and more meteophytes get eaten, they would adapt to try and not get predated on by the Parvosaurus. Remember, the animals aren't the only ones evolving too. The meteophyte's major weakness is the fact that their main plant body is above ground. This is the most important part of the plant, and unfortunately it also has the most nutrients, so Parvosaurus are more likely to eat these parts. So, in order to not get predated on, they might hide their bodies underneath the sand. These plants will be called the Pediozelli, a name meaning jellyfish fields, and you'll see why in a moment. The jellyfish-like ancestral larval stage of the meteophyte would also have some changes happen to it as well. Its eye could further develop from a simple patch of light-sensitive cells to an actual compound eye. And to gain better swimming, it may also gain 2 different adaptations. A ring of muscle around its main body could propel it through the water, and 2 of its ancestral tentacles may broaden into paddles in order to swim. The other 2 tentacles may specialize further for feeding, growing hairy, bristle-like extensions in order to catch smaller plankton. The larvae of the Pediozelli would stay in benthic environments around the adults. The larva's increase in size may call for blood, and in this case it might be pink. The ancestral cocoon may also change oh so slightly. They could gain a yellow coloration as to blend in with the sand, and would also get quite a bit smaller. This would be to allow them to get blown away by the current, in order to not get outcompeted by the adult. The ancestral meteophyte may give rise to another new clade. This clade, however, may lose its photosynthetic pigment in order to feast on something else. That something else being the abundant dead bodies littered across the benthic environment, acting in a similar way to mold or funguses of Earth. As they lose their pigment, they'd become more and more pale in colour. Their roots would also enlarge, which is where they gain their nutrients, although most of the root structure would be found inside the actual carcass. This size reduction would be prevalent in all stages of this creature's life. The leaves of this plant may not disappear entirely. They may transform into rounded bulb-like structures. This high surface area shape would allow them to produce lots and lots of gametes and spew them into the ocean, almost like spores. The cocoons would also need to find a way to stay on the body of the carcass. They may do this by growing a large serrated hook. This hook would make it so the current is less likely to blow it away, but also provide room for the roots to grow into once the adult hatches. The larvae may change quite drastically though. They would ditch their free-floating lifestyle in order to stay near the carcass. Their body and tendrils may flatten, and perhaps even a simple suction cup could form, allowing them to stick onto the carcass. These disgusting creatures would now need blood in order to sustain their new lifestyle. This may be in the form of blue copper-based blood. This unique creature will be named the Oporinatu, meaning death absorber. Now, compared to what it was before, the benthic environment is far more diverse. But that comes with a cost. The fellaxabinia have been lurking in the shadows, terrorizing whatever it comes across, alone in a basket of predators. But soon, more predators are going to take its place. A new king will take its crown, a king called Vencetheros. This monster has descended from the fellaxabinia. 2 out of 3 of its mouths have undergone specialization into arms. These arms would be tipped with touch and smell sensors, and would be used to grab and rip open prey. The throats of the arms may thin, and in some clades be lost entirely, with the only opening to the digestive tract being in the top mouth. This creature would terrorize benthic habitats, feeding on Parvosaurus, Concamis, Phodiostoma, fellaxabinia, and much more. Another killer adaptation could be small teeth in the top mouth. These would be used to crush shells of Concamis and other creatures, allowing access to the juicy innards. There would be some things the Ventriceros couldn't digest, however, one of those being cocoons. However, life has a reputation for being stubborn, so still, some Ventriceros may adapt to eat these. Enter the Rhamphophragma. This really unique species of Ventriceros could have some unique adaptations. For starters, its arms may grow increasingly sensitive, but also very muscular and strong, in order to crack open the cocoons, of course. It may also grow a hard beak. This, in tandem with its muscular arms, would be used to crush open cocoons. This creature, as well as the Ventriceros from before, may also have their back eye face forward. This provides greater depth perception in order for better hunting. The Ventriceros and the Rhamphophragma may cause lots of threats to the Concamis, as their ancestral shell might not be as much of a deterrence. This means some Concamis might fall into a new niche. Some could evolve to flip their bodies upside down, hiding underneath the sand. For this, they would be named Calimosoma, meaning hidden body. They would be sessile, clam or coral-like filter feeders, changing from their previous marine snow diet to eating passing plankton. The Calimosoma would form giant vast reefs, which would stretch for miles and be very biodiverse. In a future episode, I plan to delve into what lives in these reefs. The Calimosoma have a problem though. Due to their sessile nature, which means they can't move, once they're born, if they're in an unlucky spot, they just kind of have to deal with it. They may overcome this by having a more mobile younger stage. This younger stage would use its 3 tentacles to drag itself across the ocean floor in search of better feeding grounds. The Calimosoma filter out plankton from the water column by using bristle-like structures on their tentacles. This is known as filter feeding, but they won't be the only creatures to do this. A clade of fellaxabinia may also evolve to do this. These creatures would live higher up in the water column, filtering out phytoplankton from the water's surface. Their mouth tentacles could go shorter and shorter, but the jaws on the end of them could grow thinner and longer. These would be used to sift out plankton from the water column in order to gain nutrients. Let's call this unique fish-like creature the Imperilacami. The fellaxabinia's back-facing eye may turn into a dorsal fin, allowing for greater stability in the water, and its tail may gain a crescent shape, allowing for greater speed while swimming. Whilst the Ventriceros eats smaller benthic creatures, it might have struggle with creatures like the fellaxabinia, Imperilacami, Rhamphophragma, and more. So a new predator might evolve from the fellaxabinia, an apex predator that eats everything else in the ecosystem, the top dog if you will. Similar to the Imperilacami, its back eye may turn into a dorsal fin, allowing for great speed and maneuverability. The simple side fins of the fellaxabinia might not be enough for the high-speed chases and action this creature is willing to get into. So instead, they might elongate and flatten, turning into something similar to manta rays or possibly even Anomalocaris from ancient Earth. And its weapon, the main attraction, could be its unique jaws. They could be positioned into a triangle-like shape, providing strong crushing forces when biting. Each tentacle will have the actual opening to the mouth move closer and closer to the center. The inner jaw would shrink and be mainly used for sensing. However, the outer jaw could gain a massive bony tooth used for puncturing and killing prey. All these adaptations will make this fellaxabinia descendant the beast of all beasts. And for that it has earned the name Achmerostoma. Wow, that took a while, almost 20 minutes. If you've stayed this far, I just want to say thank you so much. ZIRA started out as a simple passion project, but quickly spiraled up in popularity. Speaking of popularity, we recently hit a milestone: 100 subs. To some of you out there, that might not seem like a lot, but to me, it really is. So, I'm thinking of doing a short special, possibly around New Year's Eve, although that's debatable. For more information, I highly recommend joining the Discord server. I'll put a link to it in the comments somewhere. You should also pop in there if you want to see some sneak peeks of the next episode, make some art, or just genuinely be part of the community. From humble beginnings as small, triple-eyed starfish-like creatures and strange blue plants, they've radiated into everything from odd blue-blooded funguses to giant killing machines to cute herbivorous tripods. ZIRA's early oceans are looking wonderfully diverse, but every single creature we've shown so far are restricted to the ocean's shallows. In the next episode, we'll be looking a little deeper and discussing what lives in the open ocean as well as the deep, dark depths.